Section 6.1 is on operations on functions. So functions can be added, subtracted, multiplied, or divided. So the notation looks like this. F plus g of x is the same as f of x plus g of x. So you're just adding the two functions. F minus g of x is f of x minus g of x. So you're just subtracting the two functions. And f times g of x is f of x times g of x. And division, f divided by g of x is f of x divided by g of x. And remember, since the denominator cannot equal 0, g of x cannot equal 0. Let's take a look at an example here. So given that f of x is 3x squared minus 2x plus 1, and g of x is x minus 4, find each function and indicate any restrictions that might exist on the domain or the range. In other words, are there any values of x, any values that x can't be, or any values that y cannot be? So to find f plus g of x, we're just going to add the two functions. So that's going to be 3x squared minus 2x plus 1, which is f of x, plus g of x, which is x minus 4. So just combine like terms. 3x squared minus x minus 3. And that's all there is to it. Just add the two functions. Now, f minus g of x, you subtract the two functions. So f of x is 3x squared minus 2x plus 1. Now, this is a little tricky. We have to subtract all of g of x, so I have to put it in parentheses. So remember what that means is it's like subtracting each term, or kind of like distributing a negative 1. So 3x squared minus 2x plus 1 minus x plus 4 minus a negative 4. Now combine like terms. 3x squared minus 3x plus 5. And that's f minus g of x. To multiply the two, I'll do f of x times g of x. And let's just distribute. I'm going to kind of do it backwards. I'm going to do x times this whole trinomial, and then negative 4 times this whole trinomial. So that'll give me 3x cubed minus 2x squared plus x. Now I'll do negative 4 times each one of these. Negative 12x squared plus 8x minus 4. And now combine like terms, which will give me 3x cubed minus 14x squared plus 9x minus 4. So just multiply the two functions times each other. And then the last one, f divided by g of x, is going to be 3x squared minus 2x plus 1 over x minus 4. And I'm just going to leave it like that. I'm not going to actually do any long division or synthetic division. I'm just going to leave it like that. However, there is a restriction on what x can be. Notice that I have x minus 4 in the denominator. My denominator cannot equal 0, so x cannot equal a positive 4, because when x is positive 4, my denominator is 0, and the function is not defined. Composition of functions. This is another way of combining functions other than addition, subtraction, multiplication, and division, in which the results of one function are used to evaluate the other function. In other words, one function is put inside of the other. And here's what the notation looks like. So we use square brackets, and an f and a tiny little circle, that's not an O, it's just a little circle, and a g of x. And we read that as f of g of x. Okay, in other words, I'm taking f of g of x. The function g of x is put into f of x for x. Same thing here, g of f of x. The function f of x is put into the function g of x, and it's read g of f of x. Let's take a look at a couple examples here. So for each set of functions, find f of g of x and g of f of x. State the domain and range of the composed functions. We call these composition of functions. Once they're composed, let's figure out what the domain and range is. So for f of g of x. I kind of like to write it like this. So f of g of x. I kind of like this notation a little bit better because it actually looks like it. Because what I'm saying is I'm putting g of x into f for x. So this is g of x, negative x plus 8, and I'm going to put that into f wherever I see an x. So negative x plus 8 goes in for x. So that's going to be negative 3 times x, and I'm putting in negative x plus 8 in for x. And now just simplify that. That's going to give me 3x minus 24. So f of g of x is 3x minus 24. G of f of x means I'm going to take g and I'm going to plug f of x into it for x. So in this case, I'm going to start with g of x, which is negative x plus 8, and I'm going to plug in negative 3x for x. So I'll have negative, and I need x, but negative 3x is going in for x, and then plus 8. So this is g of x, negative x plus 8. Now just simplify that. So that's going to give me 3x minus 8. Okay. Oh no, I'm sorry, 3x plus 8. That's right. That's not right. Yeah, so the negative there just applies to the 3x, so 3x plus 8. So g of f of x is 3x plus 8. Those are pretty simple examples. Here's one that's a little more complicated because we're going to have a trinomial here. So again, f of g of x. So I'm going to take f of x and I'm going to put g of x into it wherever I see an x. So I have 2x squared minus x plus 1. So it's going to be 2 times, now x, I'm putting in 4x plus 3 in for x, and then that has to be squared. Minus x, and then for x I'm going to put 4x plus 3, and then plus 1. So again, I start with f of x, and wherever I see an x in f of x, I'm going to plug in g of x. Now we just need to simplify this. So that's going to be 2 times, and let's go ahead and FOIL this, 16x squared plus 24x plus 9, and then distribute the negative 1, 4x minus 3 plus 1. Let's keep distributing here, so 32x squared plus 48x plus 18 minus 4x minus 3 plus 1. And now let's just combine like terms to get our final answer. 32x squared plus 44x and then that's going to give me 15 plus 1 plus 16. Okay, so that's f of g of x. Oh, and you know what I forgot to do on the last one is I forgot to say what any restrictions on the domain and range. So hold on, let me go back on that. Go back to that. I did not. Okay, so that was f of g of x. This is g of f of x, and state the domain and range. So for both of these, the domain is all real numbers, because x can be anything, and as well, y can be anything. Okay, so that's my domain and range. Okay, let's go back to this one here. So in this case, so there's my final answer. That's f of g of x. Okay, my domain can be anything. And to find my range, look what I need to do for that. is, actually there is a restriction on the range here. So think of this as y equals all of this, and I'm going to need to bring up my calculator here. Hold on and give me just a minute. I'm going to graph, because my answer ends up being a quadratic, 32x squared plus 44x plus 16. I'm going to graph it. So let's, good, I don't have anything in there. So 32x squared plus 44x plus 16. Let's see if this shows up on my graph. Okay, so there is a graph of my solution. Let me go over here. So that's y equals 32x squared plus 4x plus 16. And so what I need to do is notice that y can't be anything. What I need is the y coordinate of this point right here. So that's going to be a minimum. This right down here is going to be a minimum, so I need that y coordinate. So I'm going to do second trace. I'm going to look for a minimum. And remember, I'm going to do my left bound and my right bound, and I don't see where my cursor is right now. Actually, I think it's going a little the wrong way here. I need to move it this way. Here comes my cursor. Okay, there we go. Whoops. Okay, so I need it to the left of my minimum, and I'll hit enter. And now I need to have it to the right of my minimum. A little too far there. And hit enter. And so what this is going to tell me is it's going to look between those two lines for what's the minimum value there, and I don't want to guess. I'll hit enter again, and it tells me that my minimum is at x equals negative 0.687 approximately, and my y value, which is what I want, my y value is 0.875. So y has to be greater than or equal to 0.875. And that's how you get the range. Remember that for any quadratic, for any parabola, the domain is always all reals. The range is going to be dependent on what the graph looks like. So that's how I'm going to get my domain and range for that. Let's see, let me add another page here. And so now I am going to do g of f of x, which is the same as g of f of x. And so I'm going to start with g, which was 4x plus 3. And to start with this, and wherever I see an x, I'm going to plug in my f, which is 2x squared minus x plus 1. So this one I think is going to be a little bit easier. So 4 times x, which is f of x, 2x squared minus x plus 1. And then it was plus 3. So this is basically 4x plus 3. So 8x squared minus 4x plus 4 plus 3, or 8x squared minus 4x plus 7. So that's g of f of x. My domain, because this is a parabola, it's a quadratic, is going to be all reals, all real numbers. And my range, since this is a parabola that's going to be opening up, I'm going to have to find my minimum value of y for that. So y is going to be greater than or equal to, let's go back to our calculator, and let's put this one in. So 8x squared, what was it, minus 4x plus 7. Let's take a look at the graph of that. Okay, so I need my minimum y value. What's the y value of this minimum right here? So again, second trace, select minimum. I'm going to move just a little bit that way, so I need to be a little to the left of the minimum. Hit enter. I'm going to move over here, get a little bit to the right of the minimum, hit enter. So it's going to be looking for the coordinates of the minimum value between those 2 points right there. Hit enter, and it tells me that my minimum y value is 6.5. So y has to be greater than or equal to 6.5. Okay, so some of the things you can do with functions, you can add them, subtract them, multiply them, divide them, and do a composition of functions where you basically put one function inside of the